A-Level, Statistics 1, Probability. Conditional probability. When calculating the probability of an event happening, sometimes we are given some additional information. This may affect the outcome, so the resulting probability is called the conditional probability. For example, given a class of 25 students, of which 11 are boys and Sarah is a girl, a student is picked at random. In part 1, what is the probability that Sarah is chosen as class president? Well, Sarah is chosen out of 25 students. So the probability Sarah is chosen as class president is 1 out of 25. Now in part 2, what's the probability that she's chosen as the captain of the girls' netball team? Well, in the second case, we're given the extra information that she must be a girl, and so she's chosen from the 14 girls in the class. So the probability that Sarah is chosen as girls' netball captain is 1 out of 14. This is an example of conditional probability. We're given the extra information, only a girl can be selected. Let's look at another example. In a class of 30 students, 16 students study mathematics, 12 study physics, and 7 study neither. A student is chosen at random. In part 1, what is the probability the student studies physics? Well, to solve this, it helps if we draw a Venn diagram. First we draw the universal set, and then we draw the sets M for the mathematics students and P for the physics students. If we add 16 plus 12 plus 7, we get 35 students. But there are only 30 students in the class, so 5 must have been counted twice. Now that means the number of students that study both maths and physics must be 5. So the number of students in the intersection of M and P is 5. And now we can fill in the rest. There are 16 students studying mathematics, so that means there are 16 minus 5, or 11 students studying only mathematics. There are 12 students studying physics, and so there's 12 minus 5, which is 7, students studying only physics. There are 7 that are in neither M or P. Now going back to part 1, what's the probability the student studies physics? Well, there are 12 physics students out of 30, so the probability he studies physics is 12 out of 30, or 2 out of 5. In part 2, we're asked what is the probability the student studies physics if we know that the student studies mathematics. Well, the student is selected from 16 mathematics students, and of these, 5 study physics. So the probability that he studies physics, given that he studies mathematics, is 5 out of 16. And in part 3 it asks what's the probability that the student studies mathematics if we know the student studies physics. Well, there are 12 students that study physics, and of those, 5 study mathematics. So if we're selecting a maths student from the physics students, that's 5 out of 12, so the probability the student studies maths, given that he studies physics, is 5 out of 12. Now note, we use the vertical bar symbol to mean given that. So P, A bar B, means the probability A happens given that B has happened. Now if we look at the previous example and draw the Venn diagram, we have the probability that P happens given that M has happened is 5 out of 16. Now that's equal to the number of things in M intersection P over the number of things in M. Now if we divide the top and the bottom by the number of things in the universal set, that is the total number of things, we have it's equal to the number of things in M intersection P over the total number of things, which is the probability of M intersection P, all over the number of things in M over the total number of things, which is the probability of M. And so we have the probability that P happens given that M has happened is the probability of M intersection P over the probability of M. Similarly, the probability of M given P is the probability of M intersection P over the probability of P. Now we can write that as a formula. In general, if A and B are events, then the probability that A happens, given that B has happened, is equal to the probability of A intersection B over the probability of B. Let's look at an example. A bag contains 3 red balls and 7 blue balls. 2 balls are taken at random without replacement. Find. Now in part 1, the probability the second ball is red if the first ball taken was blue. Well, to solve this, if the first taken was blue, then there are 3 red and 6 blue balls left. So the probability of picking a red, given that a blue ball has been taken, is 3 out of 9, which is 1/3. In part 2, we're asked the probability the second ball is blue if the first ball taken was red. Well, if the first ball taken was red, then there are 2 red and 7 blue balls left. So the probability of picking a blue ball, given that a red ball has been taken, is 7 out of 9. And in part 3, we're asked the probability of getting 2 red balls. Well, the probability that the first ball is red is 3 out of 10. But once 1 red ball has been taken, there are only 2 red balls left out of a total of 9 balls. So the probability that the second ball is red is 2 out of 9. So altogether, the probability of 2 red balls is 3 out of 10 times 2 out of 9, which is 6 out of 90, or that cancels down to 1/15. Let's look at one more example. A student can either take a bus to school or walk. The probability that he takes a bus is 0.75. If he takes the bus, there is a probability of 0.2 that he will be late. If he walks, there's a probability of 0.4 that he'll be late. In part 1, we're asked to draw a tree diagram and calculate the probability that on any given day he will not be late. Well, to draw the probability tree, we start with 2 possible outcomes. He could take a bus or he could walk. The probability of taking a bus is 0.75 and the probability of walking is 0.25. If he takes the bus, there are 2 options. He may be late or he may not be late. The probability of being late is 0.2 and the probability of not being late is 0.8. If he walks, there are also 2 possibilities. He may be late or he may not be late. To be late, it's got a probability of 0.4 and not late has a probability of 0.6. Now to work out the final probabilities, we multiply down the branches. So the probability of going by bus and being late is 0.75 times 0.2, which is equal to 0.15. The probability of taking a bus and not being late is 0.75 times 0.8, which is 0.6. The probability of walking and then being late is 0.25 times 0.4, which is 0.1. And the probability of walking and not being late is 0.25 times 0.6, which is 0.15. Now for part 1, we want to find the probability that he's not late. Well, he may go by bus and not be late. That has a probability of 0.6. Or he may walk and not be late. That is a probability of 0.15. Now one of those can happen or the other can happen, and so we add the probabilities. That means the probability that he's not late is 0.75. Now in part 2 we're asked, given that he was not late one day, find the probability that he walked to school. Well, the probability that he walked to school, given that he was not late, is the probability that he walked and was not late over the probability that he was not late. That is 0.15 over 0.75, which is 0.2. So the probability that he walked, given that he was not late, is 0.2.